Hello students, welcome to this online course of engineering mechanics. So in the previous lecture we have discussed the virtual work method and we have seen where it can be applied. So today we are going to solve few problems based on the principle of virtual work. So let us start our first question. So it is saying a beam AB of span 5 meter is carrying a point load of 2 kN at a distance 2 meter from A. That is the left support. So we have to determine the beam reaction by using the principle of virtual work. So this problem can be done by the static equilibrium equation also. So you can cross check whether the answer is coming same or not. Then only it will become more clearer to you. So let us apply the virtual work principle. So it is a simply supported beam having two supports. So two supports and two reaction. RA and RB are the reaction at A and at B. So what we are going to do, either you can give a virtual displacement at end B or you can do it by giving virtual displacement at A. So I have taken virtual displacement Y at B. What you can do to cross check, you can give a virtual displacement at A also, okay, and try to solve that problem. So it will be, your concept will be more clearer, okay. So now let us start the problem. First step is you have to provide a virtual displacement and it should be compatible also. It cannot be like you cannot move point C. If this is point C, you cannot give a virtual deflection here. Either it should be ends or at the hinge. Only there you can provide the displacement. Clear? So point number one is we have to provide a virtual displacement. Now what we have to do, we have to calculate the work done by external force as well as the internal forces. And what we have to do, we have to equate them or the sum will be 0. So the total virtual work done by two reactions will be how much? So at RA you have to check the displacement. So RA there is no displacement, so 0, plus RB into Y. So why it is coming plus? Because the displacement and the reaction is in the same direction. If the reaction is like this and displacement is like this, then the work done will be negative, okay. But here the reaction and the displacement provided is in the same direction, so it is coming out to be positive and it is equal to RB into Y. Now this was due to the internal reactions. Now due to external force, that is 2 kN, what we have to calculate? We have to calculate the displacement under this load. So for 5 meters it was Y, so for 2 meters it will be 2 by 5 into Y, so it is 2 by 5 into Y. Here you can see the load is acting downwards, but the reaction is the displacement is in upward direction, so the work done will be negative. Clear? So it is minus 2 multiplied by 2 by 5 into Y. Now from the principle of virtual work, the algebraic sum of the total virtual work done is 0, because virtual work done is what? It is a fictitious quantity. It is not there, we are assuming. So RB into Y minus 0.8 Y will be 0. So you will get RB is equal to 0.8. Since RA plus RB is equal to 2, so RA will be 2 minus 0.8, that is 1.2 kilonewton. So in this way you can solve such problems. So now let us try to solve one more problem, beam problem. So it is stating two beams AC and CD, okay, of length 9 meter and 10 meter respectively. So the total span is 19 meter, 9 meter plus 10 meter, and one hinge is there at point C. These are supported on rollers at left and right ends. That is A support and D support will be your roller support, okay. A hinge support is provided at B. So B is hinge and it is at a distance of 7 meter from left support, that is from support A. So using principle of virtual work, determine the force transmitted by the hinge C and the reaction at support B when a load of 700 Newton acts at a point C meter from the right support, that is T. So in exam the figure may be given to you, or you have to draw your figure by reading the problem. So here the figure is given. If also I have not given the figure, you can just draw it by reading the problem. So again, what we have to do, we have to apply the virtual displacement. So at which point we can give it? Either it can be at ends or it can be at the hinge. So here internal hinge is provided at C. So what we have done, we have provided a displacement, and now after that we have to just we have to join the last ends, okay, like here. So what we have done, this was the beam, we have pulled it. So what is going to happen? It will be something like this. So same figure you are getting here, okay. So this is the displacement diagram. So for here the ordinates by similar triangle you can easily calculate. What is y? Y is the vertical displacement of the beam at the hinge. Now similarly, same way, what you have to do, you have to calculate the work done by the reactions that are RB, RA, RB and RD. But for the reactions, the displacement at A and D is 0. So work done will be only due to RB. That will be RB into 7 by 9 Y. Virtual work done by the external load, how much it will be? 700. But the direction is opposite, so negative sign is there, and the ordinate is 6 by 10. So it is coming out to be minus 420y. So this u1 and u2 will add and it will be 0 because total work, virtual work done will be 0. So RB you will get 540 Newton. Okay, and only transmitted by C. So RC is also we have to calculate. So RC you can simply put, let me just tell you how you are going to do this. Now what you can do, you can take the moment about C, okay, but in that case you will not, but there will be no, oh, we have calculated RB, so RB is okay, okay, fine. Now the next problem, it is looking like a complex problem, but it is actually very easy problem. So what is the problem? Two beams AE and BD, as you can see the figure, are supported on rollers at B and C as shown. So the setup is shown in the figure. Determine the reactions at the roller B and C using method of virtual work. So in this case what you can do, you can assume AE and BD as two separate beams, and at C there will be reaction in both the beams. So first we are taking, and what we have to do, you have to provide a virtual displacement at the C and at B in the respective beams. So this kind of structure, this type of diagram, displacement diagram you will get. Now for beam A, the total virtual work done by two reactions will RA and RC will be RC into I, because at A the displacement is 0 and virtual work done by external load is minus 500 into 1.2y. Just add it, you will get RC as 600 Newton, and the same RC is coming over here also. So it is action reaction. Here RC is there and here RC is there. Okay, so due to our action reaction pair, it is coming Newton's third law. So RC you have calculated from the beam AE. Now put that value in beam BD and you will get RB as 825. The ordinates I am not telling because it is very simple and you can easily calculate by similar triangle method or linear method. Now the problems were of this type. Only point load was there, but what we will be doing, how we are going to solve the problems in which the uniformly distributed load is also given in the question. So a simply supported beam AB of span 5 meter is loaded as shown. Using the principle of virtual work, find the reaction at A and B. So for a smaller span, for 3 meter, UDL is there of value 2 kilonewton per meter. So if you are having any doubt, just go to the equilibrium lectures, static equilibrium, you will get how these loads, what are the meaning of this load, why 2 kilonewton per meter is why it is per meter, you can easily understand there. So same what we can do, either we can provide a virtual displacement at A or at B. No hinge is there, so it will be a straight line. Okay, here we are providing y. So similarly at this is total 5, so for 4 it will be 4 by 5, for 3 meter it will be 3 by 5. What you have to do, you have to just write u1 in u2. What is u1? u1 is Ra into y plus Rb into 0 due to the reactions, and u2 is due to the external load. External load, what you have to be careful for the UDL part. This is same as the previous thing, just multiply the load with the displacement. But what for this UDL, you have to take the area of this displacement diagram, because the load is uniformly distributed over this area. So what we have to take, 2 is this 2 intensity into half 3 by 5 y, this ordinate into 3. So area of triangle is half base into height into base. So you have to be very careful in the case of UDL. You have to take the area of displacement diagram. This thing if you are having in mind, then it is a very simple problem. And like this you will get the value of RA and RB. RA is coming out to be 5.8 and total load is 11. 3 into 2 plus 5. 11 minus 5.8 will be 5.2. Clear? So let us see one last problem. So what is this problem stating? A weight of 100 Newton resting over a smooth surface inclined at 30 degree with the horizontal is supported by an effort P resting on a smooth surface inclined at 45 degree. So this two thing, everything is shown in the figure. By the using the principle of virtual work, calculate the value of effort P. So what we have to do, we have to provide a small displacement. Here we can provide it is x, here it is y. You can provide here also, you can provide here also. Okay, it is up to you. So we are providing a virtual vertical displacement at y, x and y. So along this we have to take the component. So it will be x upon sine 30 degree. For this will be what? X upon sine 30 degree, simple trigonometry. And similarly here it will be y upon sine 45. Clear? So as you can see here, so this will be your displacement along the inclined plane. But if P is moving by, let's say, 1 meter or 1 centimeter, the 1000 Newton will also move by the same, due to we have to maintain the compatibility. It cannot be like we can break the rope and we are moving differently. Both the load will be moved by the same amount. So that means this inclined distance along 30 degree inclination will be equal to inclined distance along 45 degree inclination. So from here you will get the relationship between x and y. So it is coming out to be x is equal to 0.070 y. Now work done by effort P will be P into y, and work done by 1000 Newton will be 1000 minus 1000 into x. Okay, vertical, we are calculating vertically. Now if P is moving here, so P is moving here, so it will move like this. So 1 will be negative. Okay, and that is 1000 Newton weight. So you have to calculate, just add these two works and you will get the effort as how much? 707 Newton. This much effort is required to maintain the equilibrium. So this is all for today. In the next lecture we are going to see about work, power and energy. Thank you.